do some massive exponent and multiplying by some tricky stuff. So let's say I took 2 cis pi over 2 and I multiplied by 2 cis pi over 2. What would happen with the 2's? They're just 2 times 2, right? Or 2 squared. What would happen to the pi over 2's? Do you remember when we multiply, we do what with the arguments? Yeah, add them, right? Now, what if I multiplied this by another 2 cis pi over 2? What if I multiplied by a third one? Now this is going to be 2 to the what? Third, and this is going to be pi over 2 plus pi over 2 plus what? Another pi over 2. So essentially, I could take this to any power I want. Let's take it to the 8th power. Okay. What will happen to my 2? It'll be 2 to the what? 8th power, right? To the 8th. But how many pi over 2's am I going to have? 8 of them, which is, by the way, simplified, is going to be 4 pi, and we'll play around with that in a little bit. But this is what they call DeMoivre's theorem. And DeMoivre's theorem is R cis theta to the n is going to be R to the n cis n times theta. I like to say it's R to the power cis theta times the power. And we're going to use that to solve this crazy problem. So the first thing I'm going to do is get you to review a little bit. Let's say I have the square root of 3 plus I, and I'm going to break this into x plus yi. What would x be in this example here? Square root of 3. What would y be? Careful. 1 times I, yep. All right. So then r, the modulus, is going to be equal to the square root of x squared plus y squared, or square root of 3 squared plus 1 squared. What's the square root of 4? 2. There's your 2 again. And then theta is the inverse tangent of y over x. Y is 1, and x is square root of 3. And you know what inverse tangent of 1 over square root of 3 is. What is it? 30 degrees, pi over 6. So I'm going to rewrite this as 2 cis pi over 6. And then we're going to take it to the 4th. Love it. Great. Now, let's do another one. Let's see, just this. Now we're going to do the second one, square root of 3 minus I. What's x this time? What's what's y this time? Careful. Negative 1. So r is going to be the square root of x squared, square root of 3 squared, plus y squared, negative 1. Don't put the I in there, please, when you square those. And that'll just be 2 again. And theta is going to be the inverse tangent of y, negative 1 over square root of 3. Now, I'm a little bothered by that. Not too much, but here's the unit circle. Here is square root of 3, negative 1. Which quadrant is this complex number in? 1, 2, 3, or 4? 4, right? In 4, do you have to add pi or subtract pi? No. So this is just going to be minus what? Pi over 6. Good. So rewriting this one, this square root of 3 minus I, we have 2 cis negative pi over 6 squared. So why did we change it into cis form? That seems like a lot of extra work. Well, it is, except now when you have 2 cis pi over 6 to the 4th, this becomes 2 to the 4th cis what? how many pi over 6? 4 pi over 6. And then this is multiplied by 2 to the second, cis negative 2 pi over 6. So what is the product of 2 to the 4th, 2 to the 4th, and 2 to the second? What's that product? 2 to the 6th, cis. What is 4 pi over 6 minus 2 pi over 6? That's 2 pi over 6. Or pi over 3. Okay. Let's work this out. What's 2 to the 4th? 2 to the 4th. 16. 2 to the 5th? 2 to the 6th? 64 cosine pi over 3 plus I sine pi over 3. And this is what we call polar form. And this is what we call rectangular form. It's just kind of nice to know the terminology a little bit. On the unit circle,
Excuse the interruption.
pi over 3, yep.
An elementary tutoring class,
Yes.
please have a go see his guidance counselor,
At the end of the hour?
now if possible. Thank you.
Okay. And so this is going to be over a half up square root of 3 over 2. So which is the cosine? 1/2? Cosine of pi over 3, is it 1/2 or square root of 3 over 2? Yep. So it's 64 1/2 plus I sine of that is square root of 3 over 2. And if you want to multiply that through, it's just going to be 32 plus 32I times the square root of 3. How weird is that? That you essentially took this to the 4th power, to the 2nd power, and then multiplied those together. Crazy, but we did it. And it's all because you can change it to cis form first, change it to cis, and then use these wonderful properties. Go to the homework. This is all I'm going to show you today. Number 10, we're going to do 5 cis 3 pi over 2 to the negative 3rd. And I'm going to try to do this one right now. What is 5 cis to the negative 3rd? That's going to be 5 to the what? Negative 3rd, cis, 3 pi over 2 to the negative 3rd. What can you do with that negative 3? Yeah, it'll be negative 9 pi over 2. 5's cubed is 1, or it's 125, so it's negative will be 1 over that. And then this one is going to be, let's think this through. Yeah, how many pi over 2's is it to go in a circle? 4 pi over 2's, right? So if I took negative 9 pi over 2 and I added 4 pi over 2, this is the same as how many pi over 2's? Negative 5 pi over 2. Because I add 4 pi over 2, I get negative 5. Add another 4, I get negative pi over 2. Add another 4, I get 3 pi over 2. So, on the unit circle, we have the cosine of 3 pi over 2 plus I times the sine of 3 pi over 2. What's the cosine here? 0 or negative 1? 0. And then the sine of 3 pi over 2 is negative 1. So my answer for this beautiful thing is 1 over 125, 0 minus 1i. No kidding, this thing cubed is negative I over 125. Pretty awesome. You try F. Go for it right now. Try F.